If we want to find the derivative at -3, or if we want to find the instantaneous rate of change when x equals -3, it's going to look very much the same as the last example, except every place I had a 2, I'll have a -3. So we're going to kick this off with the limit as h goes to 0, f of -3 plus h minus f of -3 all over h. So this is an instruction. This is an instruction to us to go to the function named f and plug in -3 plus h. When I do that, it's gonna look like -3 plus h squared minus 3 times -3 plus h. And I did not give myself enough room, so let me fix this briefly. That's moved. And this is an instruction to go ahead to the function named f and plug in -3. But again, I'm not going to actually do all the calculations. I'm just going to write it out in kind of a longhand. And that's something you guys want to get used to trying out, because it does make some things in calculus next year a little bit easier. You're not going to like it at first, but give it a try. So we'll subtract what we get when we plug -3 into this function. So that'll be -3 squared minus 3 times -3. This whole thing will be over h. So the big thing, just take a breath, take it one step at a time, FOIL this out, distribute this, maybe square this, and maybe multiply those together, but don't worry about putting them all together all the way. You don't need to do that. I'm going to pause and do that. I'm going to use a trick that I know for squaring binomials, where you square the first term and you square the last term, and then you multiply those things together and double it. Maybe you remember that from freshman year. But I'm going to pause and do that. I suggest you guys pause and do it yourself and see if we end up in the same place. If you did all of your math correctly, then this -3 plus h squared should have turned into 9 minus 6h plus h squared. This -3 times this -3 plus h should have become positive 9 minus 3h. I've got a minus sign with a big parentheses. -3 squared is positive 9. -3 times another -3 is another positive 9. I'm going to go through now, remove these parentheses, and combine like terms. We'll see that a lot of things do cancel. But when I pause, I'm going to delete or erase all this and write the new expression up here where I have more room. So once all my minus signs are distributed, my parentheses are gone, I'm going to have an expression that looks like this. And I'm happy to say, you know, lots of things cancel out, right? This 9 can knock out one of these 9s. This 9 and this 9 knock each other out. And we end up getting an expression where we can cancel the h off. It's going to look like the limit as h goes to 0. These guys are like terms, -9h plus, excuse me, h squared all over h. If you notice that every term has an h, you can cancel off an h from everybody, leaving you with -9 plus h. But if you don't like that shortcut, then what you're going to want to do is note that in the numerator there's a common factor of h that can be factored out. And then these h's can cancel. And I do have an expression where if I plug in 0 for h, I don't get 0 over 0 like I would up here. I get 0 over 0. That means there's more work to do. I can plug 0 into this and get an answer of -9. So at the end of all this, what we've discovered is that f prime of -3 equals -9, which tells us that the instantaneous rate of change when x equals -3 is -9. To put it another way, if I were to graph the function x squared minus 3x and zoom in and zoom in and zoom in on the point where x is -3, it would look like a straight line whose slope is -9. So f prime of -3 equals -9. We figured it out. That's what it means. The next example, we do a generic one just with x. And then in the example after that, I show you guys another tool on the internet that I want you to use for doing this type of algebra so that you don't have to like bog yourself down with all the tedious multiplying out of binomials and things like that. So definitely check out the next two examples, and then we'll see how things go.